This video is for class 9 physics and today's topic is atmospheric pressure and its measurement. So let us go to the topic atmospheric pressure first. Atmospheric pressure. The earth is surrounded by earth up to a height of 300 km from its surface. This envelope of air around the earth is called atmosphere. The weight of air column exerts a thrust on the earth's surface. The thrust exerted on unit area of the earth's surface is called atmospheric pressure. Thus, the thrust exerted per unit area, this unit area per unit area depends upon the CGS unit or the SI unit which you would like to take. On the earth's surface due to the column of air is called the atmospheric pressure on the surface of earth. Let us try to understand this particular paragraph. Let us consider our earth, right? So this is earth surrounded by atmosphere, right, whose height is nearly 300 km, right, whose height is nearly 300 km. Okay, now as you all know, this air, right, should have some weight with it. Because of that weight, this air will push the surface of the earth downwards from all the sides, right? Okay, so that means it is applying some thrust on the surface of the earth. Because of this thrust, right, it creates a pressure on the surface of the earth. It is creating a pressure on the surface of the earth. So this pressure created by this atmosphere is known as atmospheric pressure. Okay, I hope this is clear. Let us go to the book. Note the weight of air column over 1 centimeter square, nearly of this area, okay, nearly of this area, the red area, on the earth's surface is nearly 1 kgf. That means the atmosphere on top of this square here, okay, exerts 1 kgf of weight. So the atmospheric pressure on the earth's surface is about 1 kgf per centimeter square. That means the pressure exerted by the atmosphere on this particular area should be 1 kgf per centimeter square. Now, if I want to convert it into SI unit, 1 kgf per centimeter square will be equal to 10 Newton, because 1 kgf is 10 Newton and 1 centimeter square is 10 to the power of minus 4 meter square. We have done this in numerical problems also. Then which will be equal to 10 to the power 5 Newton per meter square, which is nearly 1 lakh Newton, okay, per meter square. This implies that a thrust of about 1 lakh Newton acts on every 1 meter square of the surface of objects on the earth. Okay, let me try to explain this. Suppose we consider earth, right? Suppose we consider earth, and like before we are considering a atmosphere on top of it. Okay, now suppose I take only 1 centimeter square on the surface of the earth, right? So the column of air above it, okay, will have some weight. That weight is equal to 1 kgf. Hence pressure exerted by this air column here, on the surface of the earth, whose area is 1 centimeter square, will be equal to, pressure will be equal to 1 kgf per centimeter square. But if I want to convert it into the SI unit, then the area will increase. Of course, the area becomes 1 meter square. Hence, the air column above it, also will increase, isn't it? right? Since the air column above it increases, now the weight of this air column is nearly equal to 10 to the power 5 Newton. 10 to the power 5 Newton. Hence, the pressure exerted by this air column here, on this surface will be equal to 10 to the power 5 Newton, right, per meter square. That is nearly, okay. I hope you understood this particular paragraph. The average surface area of a human body is about 2 meters square, right? Therefore, the atmosphere exerts a total thrust of about 2 into 10 to the power 5 Newton, which is nearly equal to the weight of 2 elephants on our body. So that means we should be crossed. However, we are not aware of this amount of pressure, thrust or pressure, right, on us, because the pressure of our blood, that is known as blood pressure, balances it, okay. The blood pressure is slightly more than the atmospheric pressure. However, at high altitudes the story becomes different. Okay, let us try to understand till here first, then we shall go to this particular statement. Okay, let us go to the blank page again. Let us consider a human body. Okay, let us consider a human body here. Okay, although it's not looking like human, but let us consider this to be a human body whose surface area is nearly 2 meters square, right? And pressure on this, because of this surface area, is nearly 2 into 10 to the power 5, okay, 2 into 10 to the power 5 Newton per meter square, that is nearly 2 lakh pascals. So atmosphere is pressing us humans, right, from all the sides with this much amount of pressure, Now that means we should be crushed, but there is something which rescues us, that is our blood. Okay, we have blood in our body. Now what does this blood do? It will also exert pressure outward to counteract this atmospheric pressure. So what does this blood do is balancing the atmospheric pressure, whose value is slightly more than the atmospheric pressure. Okay, now I think we can go to the book again. However, at high altitude the atmospheric pressure becomes less, because the height of the air column above that altitude is less than at the earth's surface. As a result, at high altitudes the blood pressure becomes much more than the atmospheric pressure, and nose bleeding may occur due to excess blood pressure. Okay, let me try to explain this. Let us consider the surface of the earth, right, and the air column above it, whose height is nearly 300 kilometers. But as you all know, we have mountains, hills on the surface of the earth. Suppose this is the hill on the surface of the earth. Now what happens if you climb up the hill? Suppose you are here, right? Now as you can see, the air above you has decreased. Is very less here. Okay, so now the pressure exerted by this small air column is very less compared to this 300 kilometer, right? Hence whatever blood pressure you had, it will not change. Okay, so the blood pressure tries to balance this atmospheric pressure and wins. As a result, you will suffer from high blood pressure, and you might have nose bleeding, okay, because nose, ears, eyes, they have small nerve endings, okay, from which the blood can ooze out. Okay, I hope you understood atmospheric pressure. Thank you so much.